Algorithms. A tour of C++, containers and algorithms. A data structure, such as a list or a vector, is not very useful on its own. To use one, we need operations for basic access such as adding and removing elements, as is provided for list and vector. Furthermore, we rarely just store objects in a container. We sort them, print them, extract subsets, remove elements, search for objects, etc. Consequently, the standard library provides the most common algorithms for containers in addition to providing the most common container types. For example, the following sorts a vector and places a copy of each unique vector element on a list. Bool operator less than, const entry address of x, const entry address of y, less than. Return x.name less than y.name, order entries by their names. Void f, vector entry address of vec, list entry address of lst. Sort, vec.begin, vec.end, use less than for order. Unique copy, vec.begin, vec.end, lst.begin, don't copy adjacent equal elements. The standard algorithms are expressed in terms of sequences of elements. A sequence is represented by a pair of iterators specifying the first element and the one beyond the last element. Iterators. Elements. Begin. End. In the example, sort sorts the sequence defined by the pair of iterators vec.begin and vec.end, which just happens to be all the elements of a vector. For writing output, you need only to specify the first element to be written. If more than one element is written, the elements following that initial element will be overwritten. Thus, to avoid errors, LST must have at least as many elements as there are unique values in vec. If we wanted to place the unique elements in a new container, we could have written list entry f, vector entry address of vec. List entry res. Sort, vec.begin, vec.end. Unique copy, vec.begin, vec.end, back inserter, res, append to res. Return res. A back inserter adds elements at the end of a container, extending the container to make room for them. Thus, the standard containers plus back inserters eliminate the need to use error-prone, explicit C-style memory management using realloc. The standard library list has a move constructor that makes returning res by value efficient, even for lists of thousands of elements. If you find the pair of iterators style of code, such as sort, vec.begin, vec.end, tedious, you can define container versions of the algorithms and write sort, vec. Thank you for watching.